Hello, hello. How you guys doing? Jill Megan out of house. Hello, hello. So today's camera's gonna be a little scuffed because I'm not turning on my big lights because it's a little warm outside. But welcome, and I know I have a green shirt on. Don't worry about it. It's fine. It's fine. How you guys doing? How's your weekend? I got almost nothing done yesterday. Aside from laundry. I was dead tired yesterday. I slept through half of it. Had a nap in the middle of the day and took up most of it. Got to go to a hotel in an hour. Oh, nice. I thought you said you were going to be in the hotel already. Oh, but nice. Yeah, so today's going to be a little bit more relaxed, I think. I'm not doing any of the TRS stuff yet. The last piece of hardware has come in. Essentially like a ROM cart kind of thing. It's FujiNet is what it's called. So it emulates disk drives and I think some other stuff. Really nifty. I still have a lot more poking around to do before I'm comfortable with this on stream. And some logistical figuring outs of actually having it on stream. So that's not today. Today I'm gonna be looking a little bit more at this turbo file. Because there are some things that I didn't do last time that I had mentioned, but I think I still want to get to. And I'll start with some light-ish refactoring of my key test code a little bit, give it a little bit of maintenance that's probably needed for a little while. But yeah. Now yeah, checked in is until 10. So I want to have my PC a bit longer. Fair. Yeah, okay. Fairly well, a bit tired today. Today's a national day, so we have some celebrations. Oh, nice. Fun. Yeah, yesterday I got my laundry done and then got back home and I was just fucking dead tired. And then like fell asleep around 5 o'clock in the afternoon. Woke up and it was dark outside, 7, 8 o'clock. Like, all right, well, should probably do something with what's left of the day. But oh well. Anyway, so where we left off last time with this, oop, that's not that. Oh, I didn't commit that yet. Oops. So where we left off last time, we read the first file, essentially, on this thing. What I want to do is I want to expand that a bunch to basically read the whole device to see if there's any more files on it, what else is there, that kind of thing, right? If it's all empty. And a little bit more visual feedback for when it's reading stuff, right? On top of that, as far as the refactoring bit goes, I want to rework the NMI stuff a little bit better, make it a little bit nicer. So with the NMI, I do have this handler pointer, essentially, right? Originally meant for this unrolled loop, but I would like to expand that a little bit to be a little bit nicer to turn that into, instead of like a where are we going inside the unrolled loop, turn it into a like a command that the NMI is going to handle that frame, right? Something like, draw from this unrolled loop, or here's a string, draw it at this address, kind of thing, right? But yeah, so we'll get there. Sounds like the beginning of a file manager for it, maybe with some file recovery features, possibly, yeah. If I start going really far down that road, I'll probably break out the majority of that functionality into its own ROM. Probably. So for now, I think I want to just do like a read-only kind of verification, kind of, right? So with the 2 file formats that are on there, I don't have that open anymore. There's a wiki. Turbo file. Add. Oh no! I need to start those when I start stream before I get into things. Yeah, you got 55 seconds. Yeah, so there's 2 of them, and I want to be able to identify both of them. Yeah. But let's start. No. Goodness. Let's start with this stuff that I'm doing here. Let's get this committed. So the pre-roll ad will be it for a while, but apparently not. Oh, well, I'm back now. Welcome back. You got a pre-roll? You shouldn't be getting pre-rolls. Maybe it's because I just started to stream. That's why the pre-roll happened. I don't know. So it won't let me trigger an ad at the very beginning of the stream. I can only run it like after 5 minutes into the stream, right? I think that's about when it triggers, give or take. So I never remember to actually fire it off to like get it out of the way. Jojo, how you doing? Welcome. Yeah, what was I saying? Yeah, so I do want to be able to identify both of these file types, right? Yeah. So there's a few games that handle that. And with these 2 file types, with one of them anyway, there is a checksum. So I do want to, like display the files, the file name, the title, or whatever, the size, the offset, and the checksum, right? Of everything that it finds valid, right? So we'll get there, I think. We'll get there. Doing all right. Just back from the dog, taking the dogs to a groomer. Oh, okay. It's gotta be hard to remember. Yeah. Yeah. So let's just commit this, I think. So we're removing the unused read controllers, because that, I guess, was removed before. Git add turbo. Add rudimentary. How do you spell rudimentary? Rudy. I was close. Fucking English. To turbo file. Spelling rudimentary. Shush. So I was ready. I was ready to actually watch more of Stream Friday, and then my dad did an impromptu visit, and then by the time he was gone, my friend was ready to hang. Welp. No worries, it's fine. Remove the unused, duplicated read controllers routine. Added code to detect a file starting at the beginning. Is it beginnings two ends? Yes. Fucking English, I swear to God. I'm off to a great start today. So at the beginning of the turbo files. Outer space. Only the first file. Is detected, and it cannot be the castle. Excellent? That's a high spell, excellent. File format. Tweaked read byte to load the red byte into A instead of requiring the calling context to do so. Oh. There we go. Okay. Saki went cold. Oh no! You bet oh my God. Double microwaved. Double nuked. How dare you? Blasphemy. What's really like turbos? Yeah, well, yeah, it doesn't it's slow. It's slow. All right, so I think I'll start with like this NMI rework a little bit. So I might let me turn off this for now. I might just start with like NMI command, have that as a thing, right? So we can put that in here somewhere. NMI command res1 enum NMI action, we'll call it. Or yeah. NMI action. First one, nothing. Then what do I want to call it? Unrolled, right? String right. Right unrolled, right string. How about that? Okay. So I couldn't think of it. The turbo button on all PCs made things slower, so did they? So I don't want to check this during NMI. I think I want to check this during the wait for NMI, right? And that will do or set up different pointers to this, right? On bytes, since they're individual bytes, distinguished from longer writes. Actually, no, we can actually just remove, because it's going to be writing something anyway. Unrolled bytes and string. Yeah, we could do that. But yeah, so I want the setup for the NMI to actually look at that stuff. To set up a pointer for that. So let's go over here. NMI string jump, NMI, done. NMI string is going to take just the first byte of actually, you know what we could do? Okay, so we could do this in here, right? Strings are null terminated, right? And addresses here. Yeah, we'll keep them. We'll keep the high and low separated, but have the ability to have more than one string buffered at a time, right? So if there's two separate null terminated strings, two separate addresses in here. Maybe. Yeah. Load up. Or actually, I need that in the loop. Or load Y 0. Loop. Load A. Buffer adder low. Ooh, I'm gonna have to use the buffer index for this. Cause I mean, that's not necessarily string that I could write there. It could be. No, I don't have character RAM. Okay, so no. Look at the buffer high. If it's 0 or less than 20, abort it early, right? Why? Compare that to hex 20. Branch. Carry clear? Right? It's carry clear for less than, I think, right? Because it does a subtraction, and if it doesn't, if it's not more than 20, the carry won't be set. Am I finally starting to understand this? Or no? Less than carry is clear, yes. Okay. All right. I'm finally starting to understand. It only took fucking 8 years. All right. So then we're going to store that into 2007. No, 6. Do I need a bit? I don't think so. No. Load A, buffer, adder, low, at Y. Store that into 2006. Oh, and I also want to load X0 as well, because that's what we're going to be using to actually read the data. Data. Load A. Buffer data at X. Branch equal to next. Okay. Otherwise, store A into 2007. Then jump to data. Compare X to size of, right? Buffer data. If it's bigger than that, branch equal to done. We've gone past the end of the buffer. Nothing left to write. Abort. And I need to increment X there. Then up here, I'm going to increment Y. Yeah. Okay. That's right, right? That sounds right. And then Namir. Am I saying that right? Hello, welcome. Draw text. So that's going to replace basically this right here. Or rather, this is going to be like buffer text, I think. I think that's what we're going to change it into. Or I could just roll it all into one and into buffer and draw, so it has the wait for NMI stuff in it as well. I think I might do that. Actually, yeah, I could just do that, where the wait for NMI just resets to nothing, right? Does the nothing call, and then have specific waits or functions for hey, I want to draw something, right? Maybe, possibly, I don't know. XFCE, yes, it is. All right. Draw tiled region. All right, remember that. This. That's a setup thing. Okay, so that's an init thing. That's not done on every frame. Okay, that's fine. Wait for NMI. Prepare NMI pointer. This guy here. We're not going to load a buffer index. Instead, we're going to... That's the wrong area. We're going to load a... NMI action. Load a NMI action. Branch not equal. Over here. Load up. No. Oh, I don't need to do it like that. I can just grab these guys, yoink. Paste it there. RTS, like that. Pressure equal to empty. Compare that to my action. Unrolled bytes, or no, call it string. Why not? Branch equal string. We can put that down here. Branch not equal to, no, compare that to NMI action unrolled bytes, branch not equal to empty. Okay. Down here, we're going to load up this, paste it there, but we're not doing NMI done. Instead, we're doing NMI string for the NMI loop pointer. That's fine to keep it like that. That's fine. All right. Then down somewhere, down here, draw text is instead going to buffer to the text and then wait for it to happen. So we're going to Ooh, you know what? No, hang on. We need to we actually do want to use that buffer address, because if we want to call this more than once, we need to know where to put everything. So this is going to load up 0, store that into buffer. No. Well, yes, but actually no. Buffer index store A, but that's going to be FF, so it doesn't screw with anything else, which means I do need to put this with the rest of this crap. In there. Okay. Oh shit! No. The string one. That no. I can't do that. No. That has to happen if it's. Whoa, that's the wrong spot to do that. There we go. Okay, that's better. Because I need to use that. Yeah. So load up. Buffer index branch plus over here. So if it's set to negative, we're going to load a 0, load y x 0. Store that into buffer. And we're gonna do that later. Jump plus load x buffer index. Okay. Thank you for this. I appreciate that. I found out where those are coming from. They're coming. Because I hooked up YouTube to the chat, which hooks up the alerts for it as well. So I don't know why I didn't think of that last time, but thank you. Welcome. How you doing? I need to theme it now. I forgot to do that, but whatever. All right. So instead of storing it into 2006, instead we're going to store that into buffer address at X. Adder high and low. Do you need to buffer index in A, or can you just index it immediately? I'll index it immediately. I am loading X. Load X. Load X. Not index, load X. Good point. Load X. If it's plus, we're good. That means we've already been in here. If not, load 0. Good catch. Thank you. Yeah, because we don't have enough space for 127 addresses, so we can't ever hit that negative. Yeah. Okay, so load that from there. And then once we do that, we need to find the end of the previous strings, essentially, right? So we need to count how many strings there are, right? Ooh, I need to clear that buffer. That's what that means. I need to clear that buffer. Is it worth another index variable to avoid needing to count? I don't know. We'll see. I need to give me a second. I'll come back to that. So load x 0, load a 0, store a, adder low at x, store a buffer adder high at x, store a buffer data at x. Now all these are the same size, so I don't have to worry about that. Increment x. Compare x to size of buffer data no. Well, branch plus. That should work. Also, you don't need to clear the entire buffer, do you? Only the first byte, assuming every new string 0 terminates. I mean, I suppose. Because if I'm looking at the index and then counting that many strings, yeah, all right. All right. I'm not going to delete that code yet. I am going to keep it commented out for now. Bridgewater, how you doing? Welcome. Won't hurt. Yeah, I mean, I'll leave it commented out for now. Okay, so we need to find we need to find the last string essentially, right? So compare x to 0. Branch equal. Found. Otherwise, we are finding the end of the next string. Load y 0. Load a. Buffer. Data. At y. Branch equal. Next find. Increment y. Decrement x. Jump to find. Otherwise, increment y. Jump, stir, find. And then at that point, in y, after here, in y is the index of what we found. And then we're going to put that into x. Transfer y to a, transfer a to x. So I can use y as pointer stuff here. Or I could just swap around x and y for all these. To not have to do that. So it's already an x. Load y 0. Load a address pointer. And then store a. Buffer data. At x. And then this, load A, NMI, action, string, jump, to wait for NMI. You want the store before the branch eagle, I think? Oh, yep, you're right. Yep. Yeah, I do want to copy the zero terminator, right? Okay, so now I need to find all instances of the draw text and make sure. Well, that should be okay. I need to make sure none of that code uses X or Y. Yeah, it looks like they're outside of that. So I can actually do that there. I'll have to wait for NMI like twice. That's that dummy read that I'm going to keep in there for now. There's another wait for NMI that I don't need to do. There or there. Grep, Mac, draw, text, start ASM. Okay. I think I need to do this while NMI's on, though. So we're going to put that down there. And this stuff isn't even fucking implemented. Oh my god. How did I forget this? How did I... What? What? How? No, what? God damn it. Well, I guess I'll be doing that too, I guess. Wait for NMI do stuff depending on the value of A. You'll need to check every wait for NMI is used too. Shit. Let's put that in X instead. Let's put that in a different variable. Doesn't matter. I'm clobbering A. I've always been clobbering A. Every time. Because that didn't change. That didn't change. That's been in there for... since the beginning, actually. Because I did the... it's a very suspicious name. I did the keyboard stuff basically first. And this is what that was for. So I don't have to worry about that. I don't have to worry about clobbering A because it always clobbered A. Yeah. Mahjong. This one. All right, I'm gonna have a draw text direct so I can use them in the inits without having to wait for NMI. That's basically just going to be the old function. Old function. Branch equal done. Yoink. Paste. I don't increment X in that other loop. 2007. Increment Y. Increment X. I need to increment both of those guys. Yes, this is going to do it directly. Oops. Yoink. Paste. 2006. 2006. There we go. Kodor, how you doing? Welcome. What's the thing about with the Nico sets A to NY string before calling wait for NY? I thought you were thought you changed wait for NY to use that value. Yes, but A wasn't ever passed into, nothing was ever passed into wait for NMI before. It was just looking at that buffer index value. But it clobbered A anyway, so I don't have to worry about it. And we're going to go back to network, that ASM, and then put that up here, and then do the direct with that as well. I need to fix that highlighting crap, but whatever, it's fine. Bill. All it means is that the load of A before the call doesn't do anything. Do I just order something wrong? Hang on. I'm not storing the fucking action is what I'm not doing. Okay. That's better. Okay. Turn that off before it kicks on. Okay. Make sure I didn't break anything. Yeah, apparently I broke something. In it. Oh God. Cool. Well, that's gonna be a pain to debug, I think. That's I don't want it in main. All right. Okay, let's try that again. I don't write zeros to the end of those. I don't write nulls, do I? Oh, because I'm writing the... Oh my god. I know why. I don't want to store that. Slappy Down, welcome. Ah, that's better. Okay. A to read. Nothing happens. Cool. Why? Like this instead. No, not like that. Like that. Yes. Okay, there's a bunch of shit in there. How am I actually drawing this shit? Turbo. Data to ASCII, draw text. Okay, well, let's actually go into read data. Right there. Papa Mouse, how you doing? Welcome. Iterate. Okay. What, pray tell, is happening here? Read byte, sure. Oh, actually, I can jump all the way down to probably here. Yep. Is that? Hang on. I don't null terminate that. It is null terminated, but I don't null terminate it, right? I don't do it correctly, I don't think. We are going to jump into here, though. All right. Plus load 0. Okay. Address pointer. Oh, 5. Okay. First one. Whoa, whoa. Am I writing to the same buffer that I'm reading from? I think I might be. I think I might be pulling some bullshit. Yeah, that ain't good. Well, I don't want that open. I want this one. Am I done? That ain't right. Did I? Branch not equal to empty. No. 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 Branch equal to empty. God damn it. All right, and I am doing some bullshit with reading and writing from the same buffer, so I do need to... What? Okay, well, my breakpoint is broken, which is cool. I don't know how that breakpoint is broken. Because it clearly reads some fucking data. What? How about there? Put a break right at the frame. The very beginning of it. Because it already goes to read file. That it hit read file. That's why. Okay, so it's not. Right. Read byte, read byte, read byte, read byte. Okay. Let's actually put a breakpoint on. Draw text. What in the fuck is this? Okay. All right. Draw text. No, I want this one. Okay. 20C5. What is C5, by the way? That's that E. Am I... What the fuck? Why is that pointing there? We're gonna have to see where this pops out. Are we using address pointer when I shouldn't? I don't think so. This is 2. Address pointer here. That's the data. That I didn't change that. I store that. Wait for NMI. Go into that. Load that. String. Okay. RTS. Jump to NMI. And this can do what it's told and draw that weird string. Commit to 20. Branch carry clear. Carry is not clear. Cool. And it draws that bullshit to the screen. Shouldn't, but it does. That should be all zeros that it draws. Yeah. Jim, stay safe. Have a good trip. See you later. Okay. Why was I looking at just 13? What? That's... Wait a minute. What? What in the shit? Oh, God. Oh, God. I see what I'm doing. God damn it. I'm reusing that fucking buffer because I didn't want to make another buffer. Guess what I'm doing? I'm making another buffer. Yeah, not doing that. I shouldn't be doing that. Oh, yeah. Oops. We're just gonna make it the same size as the other one so I don't have to change the offsets. Oh shit, I do have to change the offsets. So I'm not using the data buffers because that's already where data is, I think. Fuck, I don't remember. I'm pulling bullshit all over the fucking place. Is this the only spot that I'm actually doing data to ASCII? No, because so the address one is using that buffer because the data is using the data buffer. Okay, I need to just like not do any of that. Um, you show 16. All right. So the reason I was using the buffer data is because that was in 0 page, right? And it was already, oh, it's already a buffer. Let's use that. No, let's put it in a proper fucking buffer that doesn't need to be really that fast because it's not happening. This stuff isn't happening during fucking what's it? NMI. Now. Yeah. I'll change the +1 here and it's actually no. Low, so okay. Low. Well, these are all low. I had her to ask you, why does this one wait for NMI? Why the fuck does that wait for NMI? What the hell? Just to ask, because that doesn't actually do any drawing. It was just drawing it all afterwards. Yeah, because both of those weren't using the address buffers. So I was just using that as another general purpose buffer. Yeah. Pulling a lot of bullshit that I didn't need to do because I have so much fucking RAM available. Yeah, premature optimization is what a lot of that is. These are going to be different. Read byte, store the buffer data. This is the name, right? Yeah, it's read file. Okay. Store that into data buffer A. Data buffer A. Data buffer A. Okay. I don't want to do the wait for NMI there actually. I want to set the action. Wait for NMI elsewhere. So these should load up 2 separate buffers to the right, or 2 separate things to draw during NMI. Then I wait for it. All right, that's read file, reset address, reset address. This guy just resets it. Yeah, okay. Okay. Slowly making progress here. Make still assembles, that's good. Probably doesn't work right yet, but you know, we're getting there. Okay, so this other shit that I'm doing, loop buffer data to ASCII. No, not that. Data to ASCII. This guy here is doing a lot of bullshit. Okay, so, and these are all 16-byte buffers, right? Yeah, kinda. Load a buffer data. Ooh. Read byte buffer data. Data buffer A. Oops. Data buffer A. Data buffer A. Okay. So, all right. So this is going to, read data then expand the hex bytes, right? Yes. Yes, yes. First one's gonna be 32. And 16, 16. Actually, no, hang on. So I have it 8 bytes and 8 bytes. So that is 16. How did I draw that before? I don't know how I drew this before, actually. It's showing as 8 and 8 using 16, 16 charge. Yeah, something like that. Yeah, so let's make this one 32 again. So then these guys, data buffer B, oops, buffer B, and this one's C. Okay. Read 16 of them, gets that in ASCII. But this doesn't... Oh, because I did it twice. That... Yeah. Expanding to 2 buffers and merging that is a bit. Yes, yeah. It's expanding buffers and yeah. So it's reading 16 bytes, and then it's each byte it's interlacing that essentially across 2 separate buffers, so I can use the same index for both of them, right? So byte to hex, right? Binary to hex, and then I'm doing the combination. I'm actually interlacing them, right, into the beginning of the first buffer that originally had the binary data, but that expands to 32 bytes instead of the 16 that I read, right? Using the other index to match with it. Yes. So it's doing some shenanigans. It's doing some bullshit that's biting me in the ass right now. Excuse me. Yeah, so this... Right. So this buffers the first string. Then I add 32 and buffer the next string. You know what? This could still work, actually. Adding 17 to get past the... Yep, okay. Oh, fuck. Oh. 16 bytes, so the buffer needs to be 17 bytes. Duh. God damn it. God damn it. I need to rework this. I need to make this simpler. I don't need to make it this complicated. It's this complicated because I was trying to save space or whatever the fuck. Okay. A 16 and two 32s. Fuck it. Or, you know what? I've got the space for it. 2 16s and 2 32s. Who cares? I'll get rid of one if I don't need one. All right. Buffer A is where the incoming data is. Grab that. Shift it a bunch. Look it up. Store it into... Buffer B. A, do the same thing to buffer C. Actually, did I change? I didn't change anything except the size of these just now, didn't I? That should still work, actually. As is. There is no D. Data comes in there. Expands into there, puts it back over there. That could work, actually. Trigger's not terminating those half lines. So that's the thing. They already were. Because what I was doing is I was just adding 17 to get to the next buffer because they were already 0 terminated. Compare to y, if it's equal, store 0. And at the end, store 0. So it already was doing that stuff. And then, oh, right, this is the actual address pointer that, yeah. Editor to ASCII. This one again, this guy. Doing that. It's not how you spell that. Uh-oh. Buffer data A. And what the fuck? No, you're fine. I mean, looking at my own code, I confuse myself. So don't worry about it. Okay. Not that. 32, but it'll run into the next one, which is fine. But it runs into when it expands it, so that's okay. I don't do the proper stuff over here, I don't think. I don't think. We're gonna see. So it's not drawing two things. It's not drawing the size of the data, and it isn't drawing the address correctly. So something's going sideways. All right. Reset address. Editor to ASCII. Okay. This guy. Address buffer. Address buffer, so that's going to be all zeros. Or hex 30. Okay. Why is it... That's not... Hang on. Looking at the wrong fucking buffer. There we go, that's better. And this guy... One, two, three, four, and then the fifth one is the 0. That RTS, read a byte, compare to 41, branch equal, read a byte, compare to 42, branch equal. Read a byte, store, read a byte, store. There's the size. Adder to ASCII. Am I clobbering that before it's getting drawn? What the fuck is that? That's incorrect. Am I updating buffer index on in draw text? I don't think I am. That actually isn't going to be X. That's just going to be incremented by 1. That's all I need to do for that. Because that's a buffer into the address buffer. That's the offset into the address buffer, not the data buffer. At this point, yeah. I'll store it and increment it so I don't clobber the Y and I don't... It's fine. It's fine. Because, yeah, I need to store it first. To get that 0 in there, and then I'll increment it. It's fine. That's not what I wanted. We're here, reload. A. Where are we? Draw text. Okay. Oh, because this is nonsense now, right? Yeah, that's fucking nonsense. I need to be over there. But, I mean, we're fine, I suppose. But for index, yep, This one's going to write the 4 zeros, excuse me. 5 bytes, because it's got the 0 on the end of that. RTS, read byte, 41, 42, yep. Read byte, store, 025F. Branch plus. I guess I don't need to really load Y0 there, but I will anyway. It's fine. All right. 30. 32. 35. 46. And the 0. Okay. Read byte. Nope. Nope. We're still in, why do I have 2 of these open? Oh, I need 2 of these open. I want event viewer. What's pretty high up there? Okay. Right now it's finding that. Down to there. Buffer 46, buffer data was 10, so it should be one after that. Beautiful, okay. Right there, yep. Okay. Over here, bam. Good. Find my. By that pointer, this should work fine. Yep. There. Do that. And then go to NMI. Bam. And now this should write all three of those. Okay, it's good this time. There's zeros. Next, and we're next. Loop. Load that. I need to clear out the address buffers, is what I need to do. Or I need to use buffer index again. Because that'll just keep on writing stuff. Lucked out that there weren't more than 3, or there wasn't any data after that. How much of that data buffer do we actually use, by the way? Less than half of it. Yeah, okay. Okay, so we are going to use buffer data with that instead. Or not buffer data, but for buffer this guy. Load A, branch minus. Branch minus done. Also, if it's less than 20, we're just going to abort as well. Or go to next instead, actually. And let's have this down in next, like that. And decrement index. Like that. Okay, my breakpoints broke because of course they did. That's cool. But it worked! That's good. That's good. Okay, I don't think hitting A will work here. I mean, almost. Which Ansata uses what W is to put a line 100 before code I need a breakpoint on. Makes me move around a lot less. Yeah, well, that's fine. Okay, so now it's in read data in here. So this is what's breaking now. So we're gonna read data right there. Over here, reload. Yep. up one, A, A. Okay. So what is going sideways now? What is this? Oh, okay. I want... Did I close it? I closed it, didn't I? Don't want that. No. Okay, why didn't I see that on the... Whatever, it's fine. All right. Read a byte. Store in the buffer. I don't care about any of that. I don't care about... Okay, memory viewer. Let's actually have a look at data buffer A. That's right there. AB fleet command. It's fine. All right, move that out of the way for now. Data to ASCII. You know, it helps if I finish rewriting something. You know, it helps, believe it or not. Oh. All right. So we are going to start with this. Okay. Buffer A. So we've got 32. A bunch in buffer A. We're expanding it into buffer B and C. That's what this loop does here. That shouldn't have to change. None of that should have to change, actually. Wait a minute. Okay. Address buffer to there. There's buffer A right there. Okay. Yeah. Right. Okay. So that one is 0. Let's refresh that so we can see what it's reading from as well. Okay. Expanded it into 2. Right. C and B. Yep. Okay. Then it's taking B and then writing it on top of A again. And that is going to expand it into... Refresh that. That's going to get it the full 32. Actually, no, it's going to be more than 32. It's going to overwrite that 30 right there at the beginning of that buffer, beginning of buffer B, which is going to be fine. So long as I don't move these out of the way ever. Well, I don't move them apart, basically. So we're taking the start of that buffer. Putting it in there. Yep. The 0 right there. Then we are adding 17. Good. Started right after that. Going to the next 0. Add her to ASCII. Frame done. Frame Y. Beautiful. Beautiful. Fantastic. Okay, that looks about right. The rest of it's 0s. Good. Fantastic. Okay. All right. Fantastic. Okay. So is there more stuff that I did? That again, I'm keeping in there for now. Get rid of that. I had 16 to that. Add or ASCII, nothing really broke with that. Just thought it did. Data to ASCII. Write test. I need to remove that, honestly. All right. Okay. So now I want some. Well, first before that, actually, hang on. Hang on. We're gonna clean up. We're gonna clean this up a bit here. We're not gonna worry about. Shush. Quiet. Unnecessary. Thank you for the follow. Appreciate it. It's over here. This. I don't need to do that, so I'm not going to bother doing that. All right, and I'm going to put all these into one commit. I'm not going to split these out because it's untangling that bullshit. Yeah. Fairly separate change. Yeah, and even though I did change those other files, it's in line with what I changed with. Yeah, so I'm not separating that out. I should make sure that the Mahjong one still works. I need to rename it because it's not. I don't think it's technically the Capcom Mahjong, even though that's what's on the controller. It's named something else, I think. Right? Input. NES. Yeah, just send Mahjong controller. And I forget what I have. All this shit, man. Fuck. How did I break that? How? What? Does the direct draw? No, because that's title. That's why. Okay. Wait, what the fuck? Loop C. Press not pressed. Oh, I set those addresses fucking once and don't touch them again, don't I? That's what that is. Haha. Load A. So I don't want to be clearing any of that shit out. Okay. Nope, nope. Make. Reload. Shit. I forget again what buttons they actually are. There we go. Okay. That's better. Thank you for the follow. Appreciate it. One of them do I change? Network, which I never fucking implemented, so we're ignoring that for now. We are going to add that, but... Well. Diff main. Yeah, we're not worrying about the resetting the scroll on the direct, because that assumes that NMI is turned off. Yeah. Untangle the draw buffers. Add 3 buffers in main RAM for ASCII to hex to ASCII. That's the highest book conversions. Yeah. And don't incorrectly use the 0-page buffers. Did I hear about the stream? What stream element stuff? Oh yeah, there's 4 buffers. Yep. Yeah. Split, draw, going under. Well, I mean, how do they actually make money? That's not too surprising. Text into 2 routines, one that buffers. Text to draw, and another that draws immediately. Draw in during the next NMI. Nope, I had it right first. Yeah, that was my thought, because they won't ever monetize like Streamlabs. Yeah. Yeah, I mean, it's unfortunate. I get it, but it's unfortunate. I'll have to figure out a new service for chat stuff. Actually, I think chat is Streamlab, and it's just a bot that's Stream Elements. I think? Which one is it? Yeah, my overlay stuff is Streamlabs. It's just like the chat bot? I don't even think I'm using much of this. Hang on. Let me see what I'm actually using for Stream Elements. Just the chatbot, yeah. And honestly, I could probably replace that with a pretty simple chatbot. Like, I'm not doing much with it. Yeah. Turkish Coffee, how you doing? What am I doing right now? I am refactoring some code that I've got that handles well, it's for like figuring out a bunch of different peripherals. As soon as we're in chatbot, it's very easy. Yeah. Say, right now the current peripheral is basically like a memory card for the Famicom. But let me finish committing and I'll show you what it all does. Yeah, I could probably write mine if I needed to, and if I didn't want to, there's several others. Exactly. If it was the overlay stuff, that's a little different, because that stuff's a bitch and a half, and I don't want to have to deal with that. But I'm using Streamlabs for that, so yeah. The hell else did I do? That's basically the 2 things I did, right? Yeah. If you do webhook chat, it's okay. The hard part was the big refactor. Jojo, how could you? You could do a WebSocket chatbot in an afternoon. I mean, I think I did fucking years ago. That's what, that's the base of Movie Night, is a WebSocket chatbot. Or I didn't. I think actually you did the chatbot part of it. Didn't you? I don't honestly remember. It's been so long. That was years ago, too. I think you're the one that got the WebSocket shit actually working. Well, yes, but I mean, we built a client and server for that, right? So, okay, so let's turn this on. Oh, go over here. IRC. I mean, aren't they like deprecating that, getting rid of the IRC portion of it? Okay, good. That still works. But yeah, so it's a test round for, like, you know, making sure. Why did that break? Ah! So it should be showing me what buttons I'm pressing. It's not, because I broke some shit. Of course I did. God damn it. God damn it. This was a bitch figuring out, by the way, that I had to explicitly call the global environment for constants. You don't have to do that for anything else, just constants. Update controller, update controller, update controller. Oh, because none of these fucking... Yeah. Control lookup stuff. Debug control look at... Wait, what? Populate buttons for debugging. What the fuck does that even mean? Wait a minute. I don't have that set to true, though. Oh, what? Okay. Buffer data, increment buffer index. Load A. NMI. Action. Extend. Let's try that again. There it goes. There it is. Okay. And then player 2, carefully. Good. Oh, there's no start. Try to hit the start buttons at all. There's no start buttons over there. All right. So I need to go and add this basically to everything. Keyboard. Actually, no, that just draws the tile region, so that next paste it there. Frame. God damn it. Up there. It's probably changing core library functionality. Yeah. Oops. Oh well. Review with coding is it's finally to a point where you can guide it and it produces okay code, or have it work in a project of good code and make it okay code 90% of the time in limited amounts. Don't take your eyes off it. People still overhype it too much? Oh yeah, that's always gonna happen. We're paying way too much money for it. The $20 a month at home plan I'm paying for probably it's probably the get you hooked on it price. Yep. 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 All right, 3D glasses. This one doesn't do anything. This one just toggle shit. That doesn't actually draw anything, because that just toggles back and forth between two name tables. Hypershot. This guy is going to do that. Pretty sure. From the controller. I shouldn't be doing that way, but whatever. Yep. Yep, is there any other... What the fuck? What? Paste it there instead. Keyboard, I already did that in here. Yep. Mahjong I just fixed. Network is whatever. Standard controls are just fixed. Tablet. Does this one just do, yeah, okay, that one just does, fucking sprites for everything, I guess. Yeah. Titler. Wait for title IRQ. Why do I do that differently? What the fuck? Whatever. I'm not changing too much of this code because I know I'll break it and I don't want to break out my title right now. I do need to verify that shit still works, but not right yet. Trackball. Yeah. I think that's all of them. All right, we're going to roll this into the previous commit. Animi loop setup to use an animi action variable. Select either no action, the original unrolled loop draw, or the new buffered text draw. Yeah. That might be an interesting project. Adding titler input device support to Messen. Yeah, that's a weird one. So that's MMC3 that has an IRQ. I'm sorry, MMC1 that has an IRQ. And the IRQ is strictly for the little touchpad, right? And aside from that, okay, so the big selling point of the titler is you have video input into that, and it just writes over whatever the hell else is there, right? So do you want to like add that somehow? Have like a video input background or some shit? Or would you handle that as like, you know, setting a color that the NES can't support, right? And using that as like a, you know, color replace for recordings or some shit, which would fall apart almost immediately, I think, with any filter that you're running, right? Now, but getting the other stuff to work, like the IRQ to work, was with the touchpad. I mean, that would be, I don't want to say trivial, but easier, right? I forget exactly what the semi-transparent main emulator window. Yeah, so the trouble with that is different operating systems handle that shit differently. Right? And that's all with your compositor. So with Windows, if you figure something out, that ain't gonna work for Linux, I don't think. Right? Really annoying. Oh yeah, ungodly annoying. Yeah. Okay, so make sure we're still good over here. Where's my, there it is. Turbo file, pop, pop. Okay, so what I want to do is I want to add in this file that I have as that like write test. Yeah. Importing a video source, like you said, would be probably be easier, but rather limited and can get tricky if it should handle single step and step back and stuff properly. Yeah. And the green screen, a green screen color, a key color, yeah. Which the title of ROM kind of like almost already supports natively, because you can change the background color, right? It's just that with the titler, with one of the background colors, it is the transparent background color, right? Yeah. So the other colors are basically like, oh, you don't want it to show the video behind the thing, behind the title card. Okay, here's how you do that, right? No. Okay. So we're going to copy that to turbo.file.bin. Okay. NES. All right, key test. There, open. Remember this shitty software? Yay. So we're taking it from there all the way to the end. Delete. Save. And delete. Save. So that is just one file. Okay. So this write test, this guy here, is Reset address can pass the first. Yes. Load a test data? No. Um. Okay. Is this one, I forget if this is, what's it? Oh, cool, I broke it. That shouldn't have broke like that. Neat. I think it's bigger than 256. Yeah. Yeah. I've got a feeling it is too. Hang on. What is decrement set? Can I do this better? Can I do it like similar how I do the add carry or the increment? N and Z. Subtracts 1 and 2's complement from the contents. Yeah. Does not affect any registers the microprocessor. Does not affect the carry or overflow flags. If bit 7 is on as a result of decrement, then the end flag is set, otherwise reset. If the result of the decrement is 0, the Z flag is set. Otherwise, it is reset. I can't do it the same I would increment. Or add carry. Right? Yeah, more useful. Yeah, because for increment, if it rolls over, it hits 0. So I can check there. But I have to check against FF. So, yeah, okay. Branch not equal. Load up. Plus 0. Branch not equal. Loop. Otherwise, we're done. Right? Probably. Oh, shit. Well, hang on. Wait. Actually, And I'm going to want to unroll this loop here in a minute. There. It's terrible, but, you know, that'll work. In theory. That loop end looks wrong. Does it? So for the high address, if it isn't equal to the high loop, you start the pointer at test file and come until it's equal to oh my god, you're right. Nope, I need that. Here. That's what I need. And what I also need $20.78. Is that what I called it? Almost. Text right. Read. Okay. Let's get those on screen. And I'll do some color shenanigans. Let's move it over a little by 2. No. That's what I'll do. Okay. Now then, tile viewer. Over here. So I'm only using the first palette here. So let's change that. Second palette, we're gonna have all zeros. I don't write palette shit during the NMI, right? I don't think I do. Actually, palettes. There we go. Those need to be ZRF on the end of most of those. Okay, so you see what I'm trying to do, right? F. Make. Here, reload. Yeah. Okay. So this attribute grid. Right. So then I can write attribute to that block right there to change which is being what's being updated. And I can do that with the draw text shit too. The buffer buffer text. Attribute right. Byte is going to be fucking what? What is it going to be? For none. Add or none. Byte FF 00. Yoink. Paste. Attribute. Right. Oh, I need to use the second table for that. Can't write a 0 attribute byte. Shit, you're right. You're right. God damn it. So I can't use that. Well, I can still do that though. How's my music stopped, by the way? What the hell? How long has that been stopped? Ridiculous. You can use unrolled bytes, I think. Yeah. Yeah, I could do that way. I could do it that way. Yeah, so one is going to be 55 and the other is going to be AA, and I don't remember which. We'll find out, and we'll switch it when we find out. Not the same frame as draw text, but I don't think you need to. Yeah, so what I can do, right, test, is just fucking right here, load a... Wait for NMI. It shouldn't have anything going on. Shouldn't, because that should be clear at this point. But then, low byte of 23C6. Store that into buffer adder low and high. Yoink. My action on all bytes. No, I know I need to set the index. Is it 0 that I need to set that to? Yes. Because it's a lookup into a table. Yep. All right. And then before the RTS, yoink, paste. Can I do that? Yes, okay. Do that for both for consistency. What? Don't think I need to wait for anyone at the bottom. This here. Text needs to... Oh, right. The text needs to be zero term, right? Yeah, right. Because I'm still writing that with the... Yeah, okay. It's just the attributes I'm not updating. That didn't actually change anything. Pallets are different. Okay. I'm because it didn't actually. Okay. So two things. I didn't actually hide it initially, and it's reading right now, not writing anything. It's reading right now. Yoink, paste. Like that. Yoink that. Init. Paste. None. Why am I clearing out the buffer data here? Oh shit. Oh no. Those are direct. Never mind. That was a direct. Also, that way for anime worked? Wait a minute. I got the read and write attributes correct? Holy shit. Also, this shouldn't be taking this long, I don't think. Where the hell are we? I can hear my fan spin up. What? Did I break everything? Oh, right. I think it nuked the, Oh, nope. Okay, read data is broken. That's cool. Why? Put Jin in a buffer. It's updating a buffer with shit. There we go. And those single reads only take 1 frame. No, so it clobbered the actual instruction basically, but yeah, it clobbered the text writes. That's exactly what it did. Yeah. So as long as I wait for the frame at the end there, it's fine. Let's be after the address. God damn it, you're right. Why? Address buffer. Since you're waiting for NMI before doing the text draw. Wait. That was the wrong spot to do that. I don't want adder to ASCII. No. I want that in read data at the end of this. Not that. Actually, doesn't... That sets the action. So I don't need to do that there. I just need to wait for it. There we go. I just need to wait for it to happen. Okay. Good. Okay. So. Let's get this checksum in so I can get the read thing going, and then I'll do the write. All n bytes in the data portion added together. Just there. File size n plus 16 plus 2. Okay, so that doesn't include this or that, obviously. So just the data. Okay. Added together. Okay. So what I can do there. Read file. We'll use temp Z. What do I have first? I mean, I'm not done with it yet. Yeah, I'm not really done with it yet. Because the read and write stuff, yeah, I'll get it once I do the read. And for the read, I need to make it take a little longer, so that's what I'm doing here. I'm making it take a little longer. Temp C. Checksum loop. Read byte. Clear carry. Nope. Not switching tasks. Add carry. Temp C. Because we're already in A. It's already in A. Store that. Temp C. I don't care about carry bullshit. I don't actually care about... I don't think... Is it 2 bytes? 2 goddamn bytes. Son of a bitch. That uses no address pointers. And carry. Address pointer 1 plus 0. Nope. Okay. Now I need to subtract 1 from that address pointer, because that's length, right? No, I need to subtract a bunch first from the length. I need to subtract 18 from the length first. Set carry. Load A. Address pointer 3 plus 0. Subtract 18. Store it. Paste 1, 1, 0. Now, set carry. Load. Compare to 0. Branch not equal. Checksum. Compare to 0. Branch not equal. Checksum. Yoink. Paste. And we'll put that right underneath the name. Still that address pointer 2 plus 0. Pointer 1 isn't actually a number. That's just address pointer. Like that. Yoink. Paste. Plus 1. Load A. Compare. 2. Pointer 3 plus 1. Branch not equal. Fail. Load A. Pointer 3 plus 0. Branch not equal. Fail. Otherwise, macro draw text. That at $22.25. load a NMI action string, store that into NMI action, wait for the NMI, do the unrolled bytes one. Okay. In theory, that should work, right? Maybe? You subtracting 18 for each read? Shouldn't be. I'm modifying pointer 3. Fuck. Why? Wait, what the fuck? No, let's... hang on. Three is the one I decrement. 2 is need to be, 2 needs to be the one I compared to. No, wait. No, hang on. I'm confusing the shit out of myself. I don't... Hang on. What the fuck? Yeah, wait. Did I just confuse the shit out of myself? Wait a minute. Okay. Pointer 3 is the size. Pointer 1 is the calculated checksum. Okay. 3 is the size. That'll hit 0 eventually. Read byte, I can put that back into whatever. I can put that into 3. The checksum is what I need to... I'm not saving the checksum anymore. This. Add her to ASCII. Wait, no. No. Checksum's at the very end. What am I thinking? What, huh? This is that. Read the checksum. And I need to compare that to 1, which is... There. Okay. All right. That... Calculate the checksum. Decrement length. Validate checksum. There. That's what I needed. Oh my god. I don't know why the fuck. That's part one. Did it really read that fast? Thank you for the file. Appreciate that. I'm overriding buffers here. What the fuck? Oh, that doesn't... No. Okay, I need to... Before that checksum. I need to get that out of the buffer. I need to get that written. What the hell? Right, that is already set. You're right. This is going sideways. Okay. A friend of mine. Header 0, then the 41, 42, yep. Read byte. That is pointer. That is pointer. That is to ASCII. Draw text. O, 2, 3, 5, and fucking F or some shit, right? Yeah. Is that the carry? Two 4D. Sounds about right. Read a byte. Go there. Okay. So this. Draw text. Okay, this should draw everything that was queued up. Yes. Draws three things. Good. Now it's going to calculate the checksum. Okay. Read the checksum. 6C F4, which is actually correct. With the draw text, a single thing in the buffer. 255, okay. Oh. Oh, if there's one thing in the buffer, it increments it again. Is that right? That might be right, actually. No, because now is trying to find the second thing. No, it's not trying to find the second thing. It's just writing. No. No. I've got another. No, I don't. Okay. Okay, anyway. That's a branch minus. So it does see two things and try to draw two things when there's only one thing to draw. And it draws it where the last thing was. Right on top of the text. Or the address. And then it does the sum thing again. What the fuck? Okay. That's wrong. There we go. There we go. That's better. Because I don't want to do the increment if it's already 0. Because that's starting it out at, yeah, at 0. Shush! I guess technically I could just not worry about the load Y and then the store. Well, no, because I'd still have to increment it. But I'd be incrementing in different spots. Yeah. Yeah. So that'll work. That'll be fine. Okay. At the very beginning here, though, not there. Let me yoink that. about now. Why? I was gonna say, why is it showing the R there when I load the screen? It's showing the R there because would you believe it's reading during that? Would you believe? Would you believe it was doing the thing that I wanted it to do? Would you believe? No, I wanted to clear out that first frame where it showed both the W and R, which I did do with that. Because it only shows R. It's fine. It worked and I thought it didn't. God damn it. Okay, let's hit start. Start. Okay. Reload. All right. Neato. Let's go ahead and close out of that. Oops. No. That. No, huh? Fuck. No, I want that. Those buttons. Okay. A. Up. A. Doesn't find anything. Good. Hit start. Start. Find something. Reload. To a file. Good. Why is it only writing a single goddamn row? How did I break that now? What the fuck? It's scared if I actually move that way. That way? Yeah, that would be terrifying. Okay. One, two. Okay, got two of them. Oh, this is gonna hang on. Because I changed this shit right here. Okay. Jump out of. Buffered one of them. And it overrode it. That's why. the others won't work then? What? The hell? Wait, do I need to do an increment every time? No. I do need to increment Y though, don't I? Hang on. There we go. Okay. How was that actually working at all before? All right. Oh! Hello, hello. How you guys doing? That worked. Good. Okay. Cool. Fantastic. I have no idea how to say your name. Psycho? Oh, Psycho? I don't know. Welcome. How you guys doing? Foofpass. How you doing? Psycho. All right. That works. Hello, hello. Sick in the mind. Hello, welcome. So I am working on, that assumes that it will only ever be negative as FF, which seems reasonable. It's fine, yeah, probably fine. Yeah, because like I said, 72 is the size of that buffer, so it shouldn't ever be above 72, let alone 80. Welcome. I'm working on cleaning up some of my test code. So this is a test ROM for the Famicom to test a bunch of different peripherals. Let me hit reset and then hit start again. So I've got a lot of extra controllers and gadgets and things. And this ROM is just basically to help me reverse engineer these things and figure out how they work. And confirm that, you know, the documentation that we have is correct, more or less, right? The thing I'm working with right now is called the turbo file. Come on, Famicom. That's for the Super Famicom, you bastards. All right, hang on. Let me get a good picture of this one. Oh, you can't even see what I'm looking at here. Hang on. Whoop. Give me a sec. I'm going to get a picture of the thing I'm actually... Because I don't want to unplug it right now. And I've only got one of them. The second one's in the mail. Don't worry about it. One, and then... Over here, this guy. Come on. Load, please. Oh, cool. This. So it's a little memory card, essentially. You plug into the front of the Famicom into its expansion port. It takes some batteries. Come on. Take some batteries, and it saves your game, kind of, sort of. There's only a few games that support it. Only these games support it. And after figuring out how it worked, I understand why only those few games support it. Reading right from this thing is a bastard. It takes forever. But some of the other things that I've got in that list there are, mainly controllers, the keyboard, the family computer keyboard, the family trainer, which is like a dance pad DDR thing. Hori track is a trackball. That's on here. This guy. It's got a regular controller and a little trackball on there as well. The Oika tablet's a drawing tablet thing. So this is just a ROM to make sure I understand the devices and figure out, exactly how they work and all that kind of stuff. And like I said, today we're working on the turbo file, which is essentially a memory card, and a bunch of cleanup for this ROM to make it easier to add other things. And I do notice that I am getting to the end of that screen, so I will need to somehow introduce paging to this or scrolling or something, because I'm sure I'm gonna hit the screen limit of how many things I can have on one screen, which I think is gonna be like one more item, honestly. If that. I gotta figure that out soon. That won't be too bad, but yeah. Yeah, just gave some more screen, yeah. Basically the original hacking terminology. Yeah, more or less, yeah. Yeah, and so all this stuff I'm doing is in assembly by hand. This is hardware, by the way. So this is running on real hardware over there. So I've got hardware and I've got it's right off screen, right here. Don't mind the mess. Right here, this guy. But I'm also using an emulator that has a debugger in it that helps me figure out why the screen is all wrong. Can also use every line instead of every other, but it's only a temporary solution. Yeah, only a temporary solution, and I think it'll be a little too cluttered for that. I like the double spacing on that menu. Yeah, I don't think I want to clutter it up too much. Yeah. And I might just do, like, full screens where it's just, all right, you go to screen B now and just, have it scroll over to screen B or something like that. But, yeah. But yeah, so I do a lot of assembly work here, a lot of reverse engineering stuff. Another one of my long-term projects that I've been working on for a few years at this point is reverse engineering this guy. That's the wrong screen to do that on. This is a educational machine called the Study Box. Educational machine that has programs on tape. So you pop a tape in, close the lid, turn it on, hit play or whatever, and it goes through like an English lesson or a math lesson. And one of the things that differentiates this from other like tape-based programs like this right here for the TRS-80 that I've got in the corner, or for your Commodore or Altair or whatever the hell, the BBC Micro. This is a mono tape drive, right? So it has only a single track. I'd show you the plugs, but you won't be able to really see them. But this just stores data, right? So you hit play on these. Actually, if I've got something on this actually. So normally it just sounds like this. Right? So yeah, that's all that's on these tapes. This tape, however, has data as well as recorded audio. It's stereo. So on one channel, on the right channel, I think, is the data, and on the left channel is recorded audio. So like I said, one of the lessons, one of the courses is English. So a good way to teach English is or when you're teaching English, you want to be able to hear the language, right? And the Famicom itself can't really do recording quality audio. So they get around that by just playing from a tape. And the tape audio is fed directly to the speakers in the TV. Holy crap, welcome, how you doing? It's a 4 you. I still feel like I'm saying that wrong, but welcome, how you doing? Mamma mia. Hello. Welcome. How you been? I am doing some reverse engineering and cleanup stuff in assembly. Famicom, yes. Hello. So yeah, what I'm working on today, which up over there, is this stupid thing. This is basically like a memory card for the Famicom that only a handful of games actually use. This is actually the second one. You can see it because it says TurboFile 2. Let me go over here and I can grab the picture of the other one that I got coming in the mail. I don't want to dox my location with this. So this is the second version. The first version of it looks like this. The only difference is this one is just a single chunk of memory, right? And this one's got banks, so you can have 4 separate chunks of memory, which is kind of important because of all these games, most of them can handle more than one file on this device. Except Castle Excellent, which says, to hell to all y'all, I'm going to put my file right here. I don't care if you already have stuff there. My file is going right here. So that's probably why they decided to put banks in there, right? But these are battery backed, by the way. Little battery compartment there. This one that I have here, actually, let me turn this off. I can actually show you. This one I got here came with some horrendous corrosion on the contacts. So I opened it up, removed the contacts, and added an external battery. So it's kind of Frankenstein in there. I soldered it to the original contacts inside, cleaned it up and all that. But yeah, so this should actually work. So I unplugged it. The data on here should still be there. Let's find out. Plug it in again. Turn it on. Let's see. Start TurboFile. Look at that. We still have the file there. Fleet Commander. Yeah, Fleet Commander. And there's all the data. So this ROM here is kind of like rudimentary, making sure it works and all that kind of stuff. Why isn't it just powered over the cable? Because when you unplug it, you don't want it to lose its save data. It's battery back save. So when the thing's turned off, or you unplug it and bring it to your friend's house or whatever to play Fleet Commander against your friend, it saves the data. Fleet Commander, yeah. Yeah, like a seamless for your desktop PC, exactly. Yeah. Oh, that's before my time, tech. Yeah, so these, when were these released? Does this say? Well, all these games are early 90s, late 80s. So 88, 86, 87. So 86 is probably roughly around when it was released. Maybe a little before, or even maybe with that Castle Excellent, because this is like the first game that uses it, which is probably why it uses its own unique format. Oh yeah, thank you. I keep forgetting that. Yeah, so Castle Excellent 86. That's the earliest one of all the ones that support this. All the others support a file format where you can have more than one file on the thing. Castle Excellent just takes up the entire. Well, not even the entire. It takes up the first like chunk of it, right? But this thing has like what, 8K of ROM, right? And this file is only 508 bytes, right? Am I doing some action replay stuff? I haven't jumped into Game Genie stuff. No. There was a game jam a while ago that not a game jam, a game jam that was the restriction was the ROM had to be a Game Genie ROM. So like what, like 8K or under or something like that, and can only use the Game Genie tiles or something. That was a while back. But I haven't done anything with that. A lot of the stuff I work with is Famicom focused, not NES focused. One of the reasons is there's a lot more stuff with the Famicom. Famicom has all the weird controllers with their own, input things, the weird inputs. It's got the fucking memory card thing, right? Even Castle Excellent looks small, yeah. But yes, it's got like a trackball, right? The NES doesn't have this. It's got a keyboard the NES doesn't have. It's got a disk drive that I have underneath this thing. That's this red bit right here. Underneath. Let me get this shit out of the way. The Famicom disk system right there. It's a floppy disk drive. I don't have anything in it, and I don't have it plugged in right now. Where's the adapter for that? I don't actually know where the RAM adapter is for that. I should probably find that. Uh-oh. I should probably find that soon. Yikes. How is it spelled? The Famicom disk system? What? Family computer disk system. This guy? I need to just find it. It's around here somewhere. I think it's behind my screen somewhere. I just haven't used that in a while, so. Yeah. But yeah, it's got this. It's got a drawing tablet thing, right? So Mario Paint on the Super Nintendo wasn't the first paint program on Nintendo. It was this, Oika Kids, on the Famicom, and it used a drawing tablet instead of a mouse. Which I don't know. I think the drawing tablet for a drawing program works better than a mouse for a drawing program. But what the hell do I know? Yeah. Did I do another? Yeah, the Holy Trait, the Family Trainer. So this is a. I don't have any pictures of the whole thing, but this is like a dance mat kind of thing. Power pad, yeah. So this is the NES version, the power pad, which works differently than the Famicom version because of course it does. Yeah, power pad, side B and A, yeah. And then there's the Family Trainer mat, which doesn't. Come on, really? There, looks like this. That's one side of it anyway. Why are Wii? Okay, they made one for the Wii as well. All right, that's cool. Oh shit! That's my my picture. Yeah, and it kind of has to work differently because the connections. Yeah, but I think it works like very differently. It's not like just a connection thing. It's the way that everything's read is completely different. Yeah. Yeah, the way it's read is completely different. Control shift register strobe. Yeah, this strobes it. Because which buttons are pressed, and then this doesn't have a shift register or something, right? Yeah, it doesn't have a shift register. So it's fucking weird. Famicom is just the Japanese. Yeah, the Famicom is the Japanese version of the NES. Yep. And why do I use the Japanese version? Because there's a lot more peripherals for it, a lot more accessories. Yeah, a lot more accessories, and I have my ROM card is the more advanced one I have is for the Famicom. And my Famicom is in better shape than my NES. In fact, where is it? Hang on, I can show you my NES. This is my NES. It's in terrible shape. It does probably work. I actually have a new like edge connector here. The 3D printed case is terrible, but yeah, should actually have a better connection on it. Yeah. But the main reason I've been using the Famicom instead of the NES is because of this right here, right? I've spent a lot of time reverse engineering this, and this is Famicom only, right? What is this computer? This is a TRS-80. So I'm not working on that yet. I do plan. That's the wrong button. I do plan on doing stream stuff with this eventually. Oh, ad break. Hang on. I'll wait. 50 seconds. Yeah, I know. Yeah. I know. I need to fix, or not. I need to like have better notifications for when ads happen. Yeah. Back over here. But yeah. So that. I have it hooked up to my capture setup, but there's some things I still need to figure out with it. Yeah. Is this, what was that? It dinged on me. New items for my saves. Uh-oh. You lie to me. Oh, those are study boxes. How dare. All right. The ad should be over now, right? But yeah, so I'm not working on this. I'm not working on the TRS-80 on stream yet. I received the last bit of hardware I needed yesterday, so I'm still doing some discovery with this. And there's a bit more planning that I want to do, roadmap kind of stuff with that. But yeah, that's a TRS-80 Color Computer 2. Yeah, and this right here is the tape drive for it. I replaced the belts for this week, so it actually works. It works beautifully now. Both playback and recording. And I've confirmed that I can write to and read programs off this tape on hardware, so that's good. It's very good. But yeah, so there's still some things I need to figure out logistically with that. Yeah, because like so right now the way it's set up, I've got it hooked up and I use it on my TV, which is over there. And like I don't want to be streaming just like like this basically when I'm looking at my TV over there. So I got to figure something else. I have to figure out something else. Yeah, it's not a 6502. It's a 6809, which is an 8-bit processor, but it's like a Motorola processor instead of a the hell was it before? Moss. Yeah, Moss. 6502. Yeah. So I will be learning 6809 assembly, and to help with that, I do have some books about it, right? So I got this when I got the computer itself. It's a very nice book, this one here. Yeah, it was acquired by Commodore, but it started out as MOS technology. I've also got some Atari stuff specifically, so I'm going to need to find myself an Atari eventually. Yeah, which Atari is this for? Getting to know your Atari, page 1. Yeah, it's got some interesting illustrations. And no, you're not gonna. Okay, you can't see any of that. That's cool. All right, well. Okay, what kind of Atari is this? It's not the 2600. The Atari 400s or 800 personal computer. All right, so one of those. I need to pick up one of those then, eventually. Or this guy, because this is the manual for the Atari 130XE. Guys developed 6800, left Motorola and founded MOS and developed 252 with ideas for 6800. And Motorola sued them. Yeah, well, both of their chips are gone now. And MOS was bought, like you said, by Commodore, and they're just a name that's bought and sold now, I think. I don't even know who owns the name Commodore anymore. But yeah, that company went belly up. Motorola only makes... Well, no. Does Motorola make CPUs anymore? Yeah. They did cell phones for a while. I think they're getting out of that game, too. It's really interesting in certain ways, coming from knowing stuff. Yeah, it's got fucking address independent code, right? So it's got a lot more relative branching and jumping stuff, and yeah, the 0 page is relocatable, and there's like 2 different stacks, and yeah, really interesting shit. So I think it's going to be really interesting playing around with 6809. Yeah. It's got a multiply in there. Yeah. It's got fucking decimal mode, or the pack decimal, I think, right? Yeah. Addressing modes. Inherent, so immediate, right? Or, not immediate. Implied, right? Direct, extended, immediate. Oh, inherent, immediate. Immediate's inline, right. Simple indexed, relative, displacement indexed, auto increment or decrement, indirect, and, quote, sophisticated addressing. Sophisticated addressing. What the fuck is that? What does that mean? Sophisticated addressing? Encoding's a little different. Yeah, this doesn't have the encodings in it, I don't think. At least not as part of the main content. Oh, here we go. Detailed instruction. Yeah, okay. Addressing modes. Okay. Next, +4, +2, +6. What the hell? Yeah, so it looks like it does have the actual raw binary for each of these, which is good. Index addressing modes. Oh my god. So what is the Oh, and it's got more interrupts too. Addressing with a top hat, yeah. I don't think that word was in the day shape for any of those modes. Yeah, it's not, which is concerning. Oh yeah, it's got half carry. Apparently, a half carry bit. Yeah. EDT ASM plus. So I need to find that program, probably. Oh, wait. Binary, decimal, hexadecimal conversions. It's just a list. It's just a list. Which, I mean, okay, that's a waste of paper, I think, but sure. It's a list. It's a single goddamn column across these pages. Can you see a single column across both these pages? Like, you could put 2 columns on a page, honestly. Was the 6800 the base for the 68K? Maybe. I'm not familiar really with those architectures, so I can't really answer that with any authority. 2's complement numbers. Oh boy. Yep, same thing, where it's just a column. Positive negatives, yep. ASCII codes, okay. Starts at hex 20, so it doesn't do anything below that. Up arrow, left arrow. But no, okay. Yeah. Am I also interested in Intel 8080? Not really for the 8080 stuff. I don't really want to get into x86 at all. I don't think. I don't think. I don't know. So yeah, there isn't a good chance I'll get into that. There's not. OS/A plus Apple and Atari. Astra 1620 dual disk drive. I've got manuals for shit I don't have. And oh, there's 2 more. Okay, here you go. The last 2 books I've got. Mapping the Atari, which again is for that Atari I don't have, the Atari 400 or 800 or whatever. A lot of basic in here. No, these are fucking addresses and routines. Memory map, okay. And then Atari Basic. Then again, a lot of this is going to be relevant to what I'm going to be doing, because that's the thing with Basic is for the most part, the language itself is portable, right? I mean, there's a lot of stuff that's specific to. Oh my God, is that the keyboard on the 400? Oh, that's disgusting. Hang on. Oh, that's hideous. Jesus Christ. Ew. Is the 800 better? Okay, the 800's got a real keyboard. All right. So if I do get one of them, I'll get the 800. What the hell? Yeah, not really nice, I think, is putting it very lightly. That's fucking sacrilegious. That's oh my god. Like, no. No, just no. No wonder no one no. Well, I should say no one, but yeah, I don't know how anyone would actually be able to use that keyboard. It's like a touchscreen keyboard, but worse. Oh man, someone swapped it out with a mechanical keyboard. That's funny. That's funny. Oh shit, okay. It's a kit. No switches, no keycaps. So it's $30 for the circuit board. All right. Can I get there? It is. For the circuit board and shit to solder yourself. Got it. Managed to use it. Then we were kids and not trying to properly tap it in. Yeah. Yeah. What was another one? The ZX Spectrum, I think. Was this? No, this one had rubber keys. Still a garbage keyboard, honestly. There had to have been more computers with that shit keyboard, right? I'm gonna start falling down this rabbit hole now where I'm just collecting, you know, old 8-bit computers. Don't know the space for this shit. How, hello! Welcome. Ulrich 1. How you doing? Welcome. Snoopy Stardust. Nice. Ulrich 1. What the fuck is this? What the hell kind of abomination of a keyboard? Ew. Yeah, I use DuckDuckGo. So I don't have to deal with Google's bullshit with its AI crap. And Google has kneecapped its search results so horribly that DuckDuckGo is just as good now. Wasn't too bad. I mean, better than the Atari 400, I guess, but that's a low bar. Oh no. Oh boy, Atari 800s are cheaper than I thought they would be. Oh no. Like under $200 cheap? Lot of 265. 800 XLs. Go away. A little more expensive, but it has the disk drive and a fucking controller and a another tape drive. Because I need another one, don't I? Right? What the hell fuck kind of drive is that? What is this? Atari 10. Floppy drive. So, what's the physical size of these discs? Is it an 8.5 or a 5-inch disc? It's a 5-inch disc, isn't it? It's a floppy disk. I know these are Apple, but Google need to cap their AI to make the AI thing seem okay. Yeah. Yeah. I think it's first, when I first did basic programming and learned how to save and load stuff to and from tape. Yeah. That thing's fucking massive, though. I need to close that before I make bad choices. Worth knowing is that I think that was the first keyboard I really used, along with the flat one. So how okay it was probably colored by not knowing any better at the time. Yeah, it's one of those not really nostalgia glasses actually. That's more of that was just your first experience. You didn't know anything better, right? You didn't know what a real keyboard felt like. Yeah. Love these fucking keys, though. Cracks me up. Cracks me. I actually have some Atari controllers somewhere. I need to get a joystick or two for this thing, the TRS. Or, well, yeah, because it's these are potentiometer based joysticks, right? TRS 80 joystick. Yeah, they're analog instead of the digital of the Atari. So I can't like just make an adapter from one to the other, right? Yeah. That's a terrible one, my God. Yeah, I want to pick up one of these. At least one of them. What the hell? What kind of space program bullshit is this? Yeah, so I've got some of these. Because I've got a I have a 2600 in storage. But yeah. Anyway. Some of the ones I had on the D32. Yeah. Yeah, apparently the TRS-80 and the Dragon are more or less the same machine. Because I guess apparently the TRS-80 in general is basically just the reference block diagram for the 6800 the 6800 family in computer form, right? Like Tandy just took the Motorola documentation and went, all right, we're going to make exactly that. And I guess Dragon did something similar, right? So they're basically the same system by different companies, but like small differences here and there, right? Yeah. Apparently, I'm not 100% on any of that, but from my limited knowledge, anyway. My limited knowledge. D32 is based on the reference schematic. Yeah. Yeah, like I said, I think this might be as well. I think. Yeah. And it's got a real keyboard on it too, unlike the Atari 400. But yeah, like I said, there's a lot I got to figure out with that thing before I really dive into it on stream. Yeah. Yeah. Serial versus parallel, TV versus composite, etc. The core is basically the same. Yeah. Mine, by the way, I did modify to be composite out, so it could actually like display things. All right. So it actually works, and I can capture it. That's the last bit of hardware I had, by the way, which is the FujiNet, basically a disk drive emulator. So I can where's I can mount disks, right? And I don't have to actually have like a floppy drive. So if I put it there, up one, and then go to drives. It's mounted good. Go back. Mounting disks. And then, fuck, what is it? That. And then Frogger, yay! That looks atrocious. Is that? That shouldn't be that choppy. I don't think. Oh, because I didn't hit start yet. Or, yeah, keyboard. Okay, so while it plays, the music is choppy as hell. Got it. I understand now. Those colors are ugly and disgusting. Oh, yeah, I had it muted too, so you couldn't actually hear it, the jingle. But yeah, like I said, I gotta figure out some stuff with that. I'll figure it out maybe in a week or so, give or take. Oh yes, it's like 8, I think, colors available, but like not all at once, depending on what mode you're on. I don't know. Like I said, I gotta figure out the display modes and all that kind of shit. It's like a 32 by 16 screen, 32 by 16 character screen, which is too small for things. So Tetris is gonna be interesting getting it on there. Yeah, I don't know. There's a lot of shit I gotta figure out. A lot of shit I gotta figure out. But anyway, did I commit everything here? No. Okay. Yeah. So we're gonna get diff main. That's just that. From Cocoa Basic, for the Cocoa Basic book I've been reading, up to 4 colors at a time, 2 different sets of 4 being available. That sounds about right. Yeah. Yeah, limited, very limited. So it's gonna be interesting to see what we can do with that. The sound is atrocious. A single channel, a single yeah, a single voice on it. It's like a, what is that? A fucking square wave or sine wave or some shit? I don't know. Yeah, so the Famicom like puts that audio to shame, honestly. In graphics modes anyway, the text mode has more codes for semi-graphics. The semi-graphics are really low resolution. Yeah, it's got, like I said, it's got a bunch of weird modes that I need to figure out. Yeah, the Coco 3 has like 80 columns. Unfortunately, I don't have one of those. I've only got the 2. But Oh well, we'll figure some shit out. We'll figure some shit out. What? Oops. Add turbo. Oh, yeah. Commit. It's over here. All right. Turbo file. Add test file. Add read write feed back. Added R and W. No, display R or W when reading or writing data. When reading or writing data takes more than a single frame. Added a test file from Fleet Commander that can be written to the device when start is pressed. Will be written to the device when start is pressed. Something like artifact color available sometimes, but not reliably. You can look either orange or blue, resulting in the console, and they're setting the console can switch it. Yeah. So Frogger didn't have any of that stuff, but there's another game that I fired up, Popeye, I think it's called, and the first screen is like, "Hey, we're showing you a color. Hit enter if it's blue. Hit like clear if it's red." And I'm like, but it's green. So I think that one does some of the artifacting with it. I couldn't do anything in that one though because it needs a joystick to move. Frogger, you can actually do it with the keyboard, but that one required a joystick for it. But if I end up getting a joystick though, I can have. If I get two joysticks, I'll have all of the ports on this thing occupied, because the tape drive takes a port, the FujiNet takes another port. That's a serial I/O port. Acts as a modem and disk drive, set of disk drives. Hit any other key, right? And then there's one for each of the controllers, right? The only port actually I wouldn't be using is the RF port, because I have a composite mod in this thing. Did I take pictures of that? I feel like I may have taken pictures, but I didn't like show anybody. Hang on, I'm scrolling up on a chat real quick. Well, that's it apart. Ooh. Yeah, take pictures of this. It only works on the TV output or something. Yeah, I could see that happen. Yeah, because I am using composite, like I said. So it's not RF, and I think the artifact is an RF thing. Gallery. Camera. Yeah. Yeah, just that one. We'll do that. Where's that going? That's going to go to Discord. Over to search. There. Send. Okay. Yeah. So this was my terrible solder job, honestly. I'm not happy with that solder joint. Really, I'm not really happy with that one. These ones I'm more happy with. I didn't get a good picture of them, but a little dusty inside here too. I kind of want to get heat sinks for these, because they can get a little warm. Yeah, I think this here is the CPU right there, but yeah. So this is the composite board. Pictured here, I do not have the ground soldered. So would you believe that soldering the ground is actually important? Because if you don't, you get this. Would you believe the ground is important? So as soon as I soldered the ground or touched the ground, you know, it started working fine. But now, oop, nope. Give me this guy. Close. But yeah. So I've got these guys sticking out the back now, and I mounted them correctly, so it looks nice and clean. I went out and bought myself a drill for this, so I finally have a power drill. It only took me 20 years after moving out on my own to actually get a power drill, and I got one of those stepper bits, right? Some of these guys. I got some of these guys, right? So I can make the hole exactly how big I wanted it without, like, completely ruining everything, right? So I did it all proper. Like. Yeah. So yeah, now I need more projects for that drill, I guess. Anyway, I don't think. All right, so I think I'm more or less caught up to where I want to be with this. I think anything more with the turbo file, I'm going to. If I do anything more with the turbo file, I'm going to split that out into its own ROM. Like a file manager or whatever, or library or what have you. I was about to say, well, I can combine this with like the text editor thing I'm doing. No, I can't, because they both use the same fucking port. So I can't use the text editor because the keyboard uses the same expansion port, so I can't do that. Yeah, I'll have to figure out things to do with it, I think. Maybe, or not, I don't know. Point is, I've got a lot of figuring of shit out to do that I gotta figure out. So I think I'm gonna wrap up for today. I'm hungry, I need to get some food. But I should be back next week. I don't know what I'll be doing. I might be doing TRS stuff. No promises. I don't know yet. Depends on this week. Discovery. Maybe the 4-port splitter, except I think those might not work with the keyboard. Yeah, those splitters are only really designed for controllers, and the keyboard does a lot more bullshit on those lines, doesn't it? I think it does. So I'm not sure how well that would work, honestly. That, and I'd have to fucking buy a splitter, because I don't have one of those yet. Anyway, we're gonna raid someone, so don't go in there quite yet. I think I already know where we're going. Yeah, let's go over there. Let's go over there. Thank you for being here as always. I really do appreciate it. No, I have one for the NES. I've got the 4 score, which is a NES NES splitter thing, not a Famicom one. Right. Yeah. Anyway, I'm going over here. Thank you guys for being here as always. I do appreciate it. I will see you next weekend doing, I don't know, something. I'll figure it out, I guess. Coming through to say hi. I'd really appreciate that. And, yeah, you guys have a good night. Bye-bye.